So the format of our quiz, 40 points. You will have the full 75-minute block of time to work on the quiz, but it's designed to be a 50-minute quiz, okay, our traditional amount of time. So I'm hoping that you're not thrown off by the pacing, but obviously you need to be prepared for this, and you don't have the luxury of looking up how to do every single question that you come across. And you need to be practicing this in advance. It's one thing for you to sit there and kind of watch me explain something and say, yeah, I know that, I can do that. But then actually come to do it on Tuesday, if that's the first time, you're going to have some trouble. You're going to struggle. Okay? So it is open book, open note, but you do need to practice these sorts of problems, and you do need to practice these calculations with the calculator or GeoGebra. And you need to be very comfortable with that going into the quiz. And that's something that we will go over today. So, Canvas quiz, multiple choice, and numeric response. I was on the fence about maybe some open response, but I kind of designed those questions so that it's all multiple choice or numeric response. Okay, so nothing new on that front. Be familiar with either the graphing calculator or GeoGebra, and we'll get into that. All of these bullets here, that's pretty much what I had gone over on Wednesday when we met remotely. You can read through this, and this is a condensed outline of what we've talked about in these chapters. A couple of tables here that stand out. This one is looking at the difference between a one and a two-sided alternative hypothesis. This second table down here is looking at your types of error. Remember, we say the number of the error is the hypothesis that is actually true, but the results of your test led you to the other one. So you'll be asked to identify the possibility of, could I have made a type 1 or a type 2 error based off of the results or the conclusions from my test. We've spoken about some statistical significance. These two bullets right here. Clearly we know that a sample size that's too small is a problem. Okay? Any results that you see may not be actually what's happening in the population as a whole. Okay? But there's a chance that your test may not come back as statistically significant if your sample size is too small. But if there is a legitimacy to that, meaning that you may be onto something, but your test, you failed to reject a null because it wasn't occurring across a large enough sample. Okay? That is a possible consequence of too small of a sample size. Now, the wording that I put right here, a sample is too large, you can never really have a sample that's too large. What I should be saying is that if you have an extremely large sample size, it may be very easy to reject the null hypothesis, okay? Indicating that all you need is a slim difference between the null value and what you got in your data, in your evidence, to be able to say that that's a statistically significant difference. Your p-value will be less than 0.05. Now, when I say that it's easy to obtain statistical significance like that, there's nothing easy about having a very, very large sample, okay? Assuming it's well collected and accurately representing the population. So it's not a problem that we see too often, but especially when you're reading about existing studies or case studies, if you have a very large sample, you just need a slim difference to achieve statistical significance. Okay? Not necessarily meaning that it's practically significant. So I have some practice problems here for us, and I have our key also posted on Canvas. But some of these types of problems, like I did want to reiterate something about the language of a confidence interval. So this one says you measure the blood pressure of 25 employees of a company. A 95% confidence interval for the mean blood pressure is 122 to 138. Explain what this means to someone with no knowledge of statistics. So, you found that we typically say when we're presenting a confidence interval, we are 95% confident that the actual value is between this and this. 122, 138. The actual mean blood pressure in this problem is between 122 and 138. Okay? We stick to that script. You might be tempted to say something that you think is essentially saying the same thing, but there can be differences in interpretation like that. Like sometimes I see people want to say that 95% of the people we will survey will have a blood pressure between 122 and 138. That's not exactly what a 95% confidence interval is. Okay? It goes off of like population distribution versus sampling distribution. Remember, these are all based off of the sampling distribution. Okay? So we are 95% confident that the true mean is between here and here. That's what that's saying. A couple questions here about the population distribution versus the sampling distribution. Remember, what we had done at the beginning of the year with z-scores is comparing an individual to the rest of the population. But all of our tests and our confidence intervals are based off of the sampling distribution. You're taking a sample of size n. Doesn't matter if that population distribution is normal or not. What the central limit theorem says is if we have a sample size that's large enough, typically greater than 30, the distribution of those samples will be normal, which allows us to use these normal calculations, z-tests. So this standard error, okay, this sigma over square root of n that we've seen, is the step size for our sampling distributions. Okay? What had been sigma in the population, we're now referring to it as standard error of the mean, SEM. That is our step size. It's going to be a little bit smaller. You can see how the sample size directly influences that. If you have a bigger sample size, you're dividing by a bigger number. So that step size is going to get smaller. They're inversely proportional. So a few practice problems there. This is the problem that I'd like us to serve as kind of a walkthrough for our work today. We have a set of raw data here. There are a couple of problems like this on your quiz where you have sets of raw data provided for you, and there are several questions based off of this data set. So I want to walk through this once with the graphing calculator, refamiliarizing ourselves with how we perform these calculations. And then once we do the full problem, I just want to then show you GeoGebra. We're not going to redo the problem, just show you how those calculations are performed. Okay? So take out your graphing calculator if you have it with you. I have two right here. Does anybody want to borrow one for right now?
I borrow one.
Yeah.
Thank you.
All right. So this says the approximate costs in hundreds of dollars for 30-second randomly selected spots for various cable networks in 17 randomly selected cities are shown. So we have 30-second commercials on local cable television costing, these are in hundreds of dollars, so this would be $1,400, $5,500, and so forth. We can just deal with the numbers that are on the chart. So we're going to start by entering this data into L1 on the calculator. So I'm going to bring my calculator up, so in a few seconds this screen won't be here. If you want to pull this up on your canvas so that you can see this, please do so. Get my chair here, so a little more comfortable in the driver's seat. Second. Okay. Now, we're doing a lot of work from this stat menu on the calculator, okay? Or stat button, I should say. And to enter data on the list, you know, it's our first option right there. We're just carefully typing these 17 numbers in. Now, I've said this before, that a lot of times, if people make mistakes on this, it's not necessarily because they're confused with the procedures with the calculator. It's because they've typed in a number wrong. Okay? Be careful. I know ideally we'd transfer a data set to you. We can do that with some assignments and projects and stuff, but I'm hesitant to do that on a Canvas quiz where you have to download a set of data. Okay? So that being said, I try to simplify the numbers. Okay, I put everything in hundreds, so you're only entering 2- and 3-digit numbers here. Secondly, it's an admittedly small sample size. Okay, if this was a real issue, we know that would kind of sacrifice the integrity of our results. But for our purposes, we want to keep it simple. We only have a sample size of 17 here. Okay, so once you've carefully entered that data into L1, our first couple questions. Calculate the mean and the standard deviation of this sample. All right, there's nothing new here. These are just descriptive statistics. So back on that stat button, over to the calculate menu, 1var stats, and we are finding our sample mean X bar, 51.47. Okay, I did not tell you where to round here. On the quiz, I do tell you where to round, so pay attention to the directions. We are also asked for the sample standard deviation, which is SX, so 45.98. Now, if we were not provided with the population standard deviation, we typically use that sample standard deviation for our tests and our confidence interval. In this case, you'd probably round that to 46. Right? But looking ahead, the question tells us to use a population standard deviation of 45. So we'll be using that as we continue on with our tests. And letter C, it says construct a 95% confidence interval for the mean cost of a 30-second advertisement on a cable network. So we're going to press stat once again. Over to the tests menu. Now for this quiz, we only are going to use 2 of these. A z-test and number 7, or z-interval for a confidence interval. Right? The other tests, they will be options for us coming up in the near future, but for right now, only options 1 and 7. On letter C of this problem, we want the confidence interval. So let's go with number 7, z-interval. As I had introduced this to you before, we have 2 menus here. We can either give it all of these statistics that we have, or because our data is in the list, we can work from this data menu and it pulls relevant information like sample size and sample mean from L1. It does give us a space to enter the population standard deviation. And in letter D, I should have put it in C as well, it says that we're going to work with a population standard deviation of 45. So let's put that 45 in there. Everything else it gets from the list. 95% level of confidence. We hit calculate. There we go. 30.079 to 72.862. As our confidence interval would be presented, we are 95% confident that the actual average cost of a 30-second local cable TV commercial is between 30 and about 73, or in this case, it would be the equivalent of $3,008 to $7,286 if you took that out to the full places, because these were in hundreds. Don't worry too much about that. Any questions so far? Continuing on, letter D, now we're performing the Z-test. It says that the cable company advertises that the average price for a 30-second commercial is really $4,000, or $40 if it were on this chart. So we're skeptical of this mean, because we see that we took our sample of 17 and we got an average of 51.5 almost. And they're advertising that the average is 40. So we want to test to see if there is a difference here. Okay? So we're performing a hypothesis test, and our null and alternative hypotheses, we want to state them. The null hypothesis is that the cable company advertises that the mean is 40. So mu is equal to 40. The alternative hypothesis, we're testing if there's a difference. And there was no implication of direction in that question. So we're going to set it up with a two-sided alternative hypothesis that mu is not equal to 40. Notice that our sample value does not appear in the hypotheses. The hypotheses are always in reference to the population values. Okay? This 40, this 40. We're told that the mean is 40. Okay? Same number in both. So that answers both D and E. It's a two-sided alternative hypothesis. We want to perform our test so we can find the z-score and the p-value. So once again, stat over to tests. We want our first option of a z-test. And I forgot to change the screen back. Sorry about that. And of course it kicks me out. You've heard the things like you spend like 2 years of your life like waiting at red lights and stuff like that. I feel like I'm wasting like the equivalent of like 2 days just waiting to switch screens back and forth because it's so backwards here. Little rant. All right, so on the calculator, again, we are in stat and tests, and our very first option, z-test. Now, like the confidence interval, it could be from the stats menu where we just feed it all of the statistics that we have, or because we have our data entered into list 1, just have it pull from there. And the numbers that you need to provide are obviously that the null value of 40. And that's from our hypotheses, mu sub 0. It carries over that population standard deviation of 45 from when we were working with confidence intervals. And we also need to tell it the direction of that alternative hypothesis. This was two-sided, so we're going to go with the not equals. Go down to calculate. And here we are, z-score of 1.05, p-value of 0.29. What this means, on our normally distributed sampling distribution, we have 40 right there at the center. Our sample was 51.5 approximately. That is 1.05 standard errors above the mean. So the amount of data in the tail, we could use our z-score chart, but we get a p-value 0.29. Now, because this is two-sided, the data in one of our tails is going to be half of that, about 0.145. But it's two-sided, so we double that on our symmetric curve to give us our full p-value of 0.29. Either way, p-value is greater than 0.05, we fail to reject the null hypothesis. We're saying that 29% of the time we would get 40 or expect 40 and get something like 51.5 or more extreme. We get that 29% of the time just due to natural variation alone. Not very rare. So we fail to reject the null hypothesis, meaning we believe the null is true. And we don't want to say we accept the null hypothesis. Just like the jury never comes back and says, we find the defendant innocent. We find the defendant not guilty. Maybe that evidence is there to convict the person or to reject the null, but we didn't see it in our sample. Okay? So, we fail to reject the null hypothesis. We believe the null, the first hypothesis, is true. Now, let me flip screens back over to our questions here.
Now, in case someone forgot to write it down earlier, with regards to the overall how to use the calculator to find these answers to the equations, or not answers to the equations, but like how to find the equations themselves.
Yeah.
Do you have that somewhere as a slide?
The equations themselves?
Yeah.
I
Not
have
the equations themselves, but like how to use the calculator to get to that. Because I
like written
every
instructions.
time you run it through, I don't have my calculator, and I realized after you left the calculator thing where it was underneath my sketchbook. And I don't remember usually how to do that, and I don't want to have you run through it again and again and again. It would just be easier if I write it down.
I don't have this written. I don't have this written down. There are instructions, I believe, in the textbook that you can take a look at. But again, I am recording this one, so you can take a look at this video and this walkthrough again and watch it knowingly with the calculator beside you.
Oh, all right.
If that works. Okay.
That makes everything much easier. Hi, future me. I can't hear me.
All right. So, just as important as doing the calculations, interpreting our results. So, our next part of this 8-step process. Interpret your decision into plain English for someone who has no understanding of statistics. Well, we failed to reject the null hypothesis. Okay? Using that sort of language, that's not good for somebody with no understanding of statistics. What this would mean is that the cable company's advertised claim that it costs an average of $4,000 for a 30-second local TV commercial. We do not have any evidence that that's not true. Okay? The evidence that we collected, yeah, it was a little bit different than that, but it was not different enough to arouse suspicion that their claim is false. Okay? Now, that was only across a sample of 17. So, maybe that difference that we saw, okay, because our evidence did differ by $1,000, more than $1,000, maybe that evidence is significant enough, but it wasn't holding true across a large enough sample. And that leads us into the possibility of an error, a type 1 or a type 2 error. Remember, the number of the error is the hypothesis that is actually true, but you did the other thing. You chose the alternative. I shouldn't use that word. But we said that the first hypothesis, the null, is true. So that leaves the door open for a type 2 error in this case. A type 2 error would mean that we should have rejected the null and accepted the alternative. But we didn't have convincing enough evidence in our sample to do that. So the consequences of that, well, they're not as potentially catastrophic as what we saw when we were talking about the false negative medical tests, or like having an innocent person sitting in jail. But that would mean that this cable company, they are claiming that we have an average commercial cost of $4,000 when that's really not true. Okay? When it's different than that. Can we quantify the likelihood of this error? No. Not for a type 2 error. And that's what makes a type 2 error a little bit more challenging to determine. Is that we don't know how common that is, because we don't know what part of the alternative hypothesis we're missing. A type 1 error, the probability of that is the p-value. Okay? So if for some reason we had set like a really high alpha of 0.3, we're okay with 30% error, then our p-value of 0.29 is less than that. We'd reject the null, accept the alternative, and we're okay with our 29% chance of making a type 1 error. But that's probably not the case here. Okay? We cannot quantify a type 2 error. Any questions on that process? Again, be familiar with how to do this with the calculator. I'm just going to show you the GeoGebra side of it right now, in case that's a little easier for you. They're about even, I think, in terms of complexity. All right, so give me a second to just get GeoGebra up and running for us here. Okay, so like we've been doing a lot with GeoGebra, we're working from that probability calculator perspective. If we need to find the descriptive statistics like we started this problem, find the sample mean, find the sample standard deviation, we do want to bring in the spreadsheet. And we just do that by, from the view menu, we see spreadsheet. And I've pasted our data in from a previous class. And all you need to do is select it and go up to this thing that looks like a histogram, or one variable analysis. What that does is it gives us the histogram, okay, which we don't really need right now. We don't need to see the distribution of our data. We can see that it's not normal, right? It's skewed a little to the right. Most of our data is down below. But there are a couple markets that have a very high cost of a television spot. What we want is the descriptive statistics. So that's this button right here, sigma x, and it gives us what we saw with the 1var stats on the calculator. We want sample mean, 51.47, and sample standard deviation, S, 45.98. Once we have those, we can X this out, and we can X the spreadsheet out too. You go away too. We're going to work from this stats tab, statistics, and this is where we perform our tests. And from this drop-down menu, the two options that we have available to us right now, z-test of a mean and z-estimate of a mean. The z-estimate is the confidence interval. So let's select that. And just like we saw with the calculator, we're just providing it with the values that we need. Our sample mean was about 51.5. A little bit of rounding I did, that's okay. We were told our sample, or our population standard deviation was 45, and our sample size was 17. And once we enter that data, our chart down below fills itself out. Lower and upper limits of our confidence interval, 30 to about 73. And same thing we got with the calculator. For the z-test, that's our very first option. It knows a lot of the values that we entered from confidence interval. We just need to provide it with that null value and reaffirm the direction of the alternative hypothesis. So our null value, cable company says it's $40 or $4,000. We had a two-sided alternative, so let's leave that as not equal to. And our table completes itself down here. Z-score 1.05, looks familiar. P-value 0.29, looks familiar as well. Okay. Same kinds of conclusions. Need to sit down. Be lazy. Any questions with either the calculator or GeoGebra? Good. All right, so coming back here. On your review, a couple more problems. This key is available on Canvas right now. My suggestion, don't look at the key. Okay? Try the problems on your own first. Sometimes we get into bad habits of just kind of looking through the key or immediately looking at the key. Like, yeah, I can do this. Yeah, I can do this. Oh, I'm a little stuck. Let me look at the key. Yeah, I can do it. You have to practice this stuff. That's the only way you will get better. If the first time you are doing these types of problems is on Tuesday, that's not a good thing. You need to practice and try this on your own in advance. Don't worry about number 9. When I was collecting review materials from my old sources, I thought that this would be a good fit for this section, but it's not. We haven't learned these other tests yet, so it doesn't make sense. There's another walkthrough problem with some raw data on the last page, talking about average light bulb lifespan, similar to what we had just done. So here's a blank problem for you to try. Yeah? See what you can do with that. But the key is available on Canvas afterwards. All right, any questions that you have? So, we have some time now, 20 minutes. I want you to use this to start practicing a little bit. Start with this, and then we also have those review questions from the textbook that I created as an assignment. They are available to you as well. Okay, so do what you want with those. Those answers are there on Canvas, but please be practicing. If questions come up between now and Tuesday afternoon, you guys are at the advantage where you have a couple days where you could sign up for academic resource time or meet me in the link at that time to go over anything. Okay? But make sure you're practicing, make sure you're prepared. All right, so let's go ahead and get started with that now. Yeah, go ahead.
Sorry, that was an accident.
Oh, okay, all good. All right, so go ahead, get started.